Hello YouTube, this is umils03. So in the previous video, we introduced a few concepts in regard to object-oriented programming. And we said basically what we can do is we can create a type of class. Okay, so we can create our own blueprint for a new data type or a new object, a new type of objects that we want our program to keep track of. And in our particular example, what we did is we created a person class. And we'd completely defined what a person class is. And we said basically what a person class will have, what any class will have is number one, it'll have parameters, it'll have fields. So for example, we have a string called a person's name and an int called a person's age. Okay, and so that's for our particular example, we just have a string and an int. But if you were talking about someone's house, for example, maybe you could have Booleans, false for off, or true for on for the light switches, right? So you could be thinking about variables where there are only two possible values, or you could be thinking about characters. What's someone's favorite character? Is it a lowercase y? Is it a backslash, or is it a right square bracket? So anyway, so you can have these instance variables here. You need to just declare them at the top of the program. And then we have a constructor, and we said that a constructor is a special type of method where we basically pass in some string, which we're arbitrarily calling n here, and some ints, which we're arbitrarily calling a here. And so the constructor simply assigns the person's name to whatever n is passed in, that's string, and their age to whatever int is passed in, so that whatever age is passed in the a, okay? So it's very important that you write the order of these two parameters in this particular way. So you have to have a string and then an int. Okay, this constructor would not accept an int and then a string, but in this video, we're going to come up with a way. We're going to basically be talking about the fact that you can have other types of constructors. So you can have other ways of passing in arguments rather than just, a string and then an int. So anyway, we can have a public string get name. So what I maybe didn't say in the previous video is that you need to write the return type, just like what we saw in the two videos on static methods. I think last video I was saying that they were lessons 19 and 20, but they're actually 20 and 21. So those are the lessons on static methods. But remember that we had the return type, okay? The only difference is now we don't write static, because get name and get age are examples of instance methods. So we call them on a particular object of a class or a particular instance of a class, okay? So they're not standalone methods. Like it's not f of x is x squared plus 1, right? You wouldn't have to create a person. A person wouldn't have to be born, right, in order for you to put value of x into f of x is x squared plus 1. So these are examples of instance methods, right? So you have two instance methods, and this one returns a string, which is their name, and this one returns an int, which is their age, okay? Just like you would think of with the names. So you want to have intuitive names here. And then you also have two more instance methods, and we said that these are the setter methods. And so these are void usually, okay? So we're not setting set name or set age equal to something, but we're basically setting the name or age equal to whatever they pass in when they call this method. So it would be something like if you have a person P, you would say just P dot set name of Tom. And then after the person object P was created, then they would be changing their name to Tom. So maybe they were unhappy with what they were born with or something. But that's the example that we have here. So how many methods in total do we have here? So we declared two instance variables, and we basically have 5 methods for this example. Okay, we have one constructor, which is responsible for creating an object. We have 2 getter methods, which is responsible for retrieving the values of the 2 instance variables that were initialized in the constructor. And then we have 2 setter methods. So these are also instance methods. These are setter methods, which will modify the values of name or age, the 2 instance variables, after the person object was already created. Okay, and we can make descriptions of that here. So this is a helpful review. So this is what basically be an instance method, which retrieves, or more simply gets, an integer. That's why we have int in the method header. Their age, the person's age, okay, that object's age, okay. whatever we're calling it on. Okay, so we created a particular object, so we created a particular instance of a class. And so when we call get age on that instance, it returns whatever their age was when it was created. Or if we changed it, then it would return the updated age. Okay, so this would be an instance method which modifies or sets a string, you know. So this would be, that's why you see, or this would be, because it sets a string, but the return type is void, doesn't return anything, right? So completes a task, but doesn't return anything. It certainly does something, and if you want something to be returned after you set the name, you would call the getName method, and you would make sure that the name was updated. But the setName method itself doesn't return anything. So it modifies a string, you know, their name. And then you could have a similar description here. So you would say an instance method which modifies, you know, the integer that represents their age, okay, whatever x is. So 5 methods total, okay, and a declaration of 2 instance variables. So we're not talking about an enormous amount of code here. And 80% of those 5 methods are one-liners, right? So pretty simple here. And so we can go ahead and compile it. And then we were looking at the person test here. So you can see in the BlueJ here, if you're talking about 2 classes, sometimes they just appear as tabs here. So what you could do is you could just click on person tester. And remember, this is the example from the previous video. And so we just created a person object, and the variable name was P here. And so we gave them a name and an age. So remember, in the constructor, it mandates that we feed it in a string and then an int. And then we returns their name and make sure that we got Tammy. Okay, and so we can make sure that we get that. So compile it, so we should get 38. And then for here, if we're setting age to whatever their current age plus 1 is, then that will be 38 plus 1, which is 39. So then we should get Tammy, 39. And then down here, we should get 44. So this is all a review from the previous lesson. So that's 7 minutes and 20 seconds. So I can already see that this video is going to be a little bit longer than the last one. So those are Tammy, 39 and 44, just like we should be expecting here. So now what we're going to do is we're going to make a few modifications to the person class. So the first thing that we're going to talk about is the fact that we can have a default constructor. So what we have here is a constructor with parameters. So this is a constructor with parameters, right? So basically we feed in 2 inputs, a string and then an int. We can also have what's called a default constructor, and basically a default constructor creates a default version of an object, a default version of a default object if they don't pass in any inputs. So what if you just said, oh, I want to create a person object, but you didn't specify a name and an age? Well, the default constructor gives you basically a way to give them a default name. And so you could give them a default name like, you could say something like Claire. And you could give them a default age, something like 29. And so basically, if you just said person X equals new person, and you left the parentheses empty here, basically it would set that object's name to Claire and that object's age to 29. Could you still call the setter methods on this object? Certainly. So you can call the setter methods and the getter methods regardless of which of these 2 constructors you use to create a person object. But this one is called a default constructor. So it's the exact same thing as a constructor without parameters. And it's called default because it assigns default values to the 2 instance variables that we have in our particular example here. So this is called a, so hopefully this is clear enough by now. So this is a default constructor, assigns default values to the instance variables if no parameters are specified when an object is created. So hopefully that's clear to you. Hopefully that's kind of intuitive. And so that's called a default constructor. So we can go ahead and let's do an example. So we're going to go ahead and compile it. And hopefully you can have a prediction of what kind of name and age we're going to get. So now what we're going to do is we're going to clear this sandbox example code, and we're going to say person y equals new person. Okay, so this is an example where we're declaring a person object, and this is where we're initializing a person object using the default constructor of the person class. So now what are you expecting for the name? Is it going to just return blank, or is it going to return something? So now if we say, for example, we can practice variables here. So we can say string z equals y dot get name. So what are we doing here? We're declaring a string object, but we're not saying what it is. We're just calling it z. Hey Java, I want you to keep track of a string called z. And on the next line, we're initializing it to whatever the string is that is returned when we call the getName method on the person object y. So we remember that this person object y was called using the default constructor. So if you look at the default constructor here, what does it do? It assigns that object's name to Claire and that object's age to 29. So hopefully you can hopefully you are able to predict what we're going to see when we call the getName method. Okay, so it's calling the getName. What does getName do? It returns the name, which was assigned to Claire in the default constructor, right? So we create the object and then we can call the getName. Okay, it wouldn't make any sense to call a getName or a getAge until you've called one of these two constructors. So now, you can't work with an object until you've created it. So essentially, so hopefully you can predict that this is going to return Claire. So what we're going to do is we're going to compile here and we're going to close. And oh, well, there was no console window because we actually have to go ahead and say system.out.println of z. Okay, so this line assigned z, it initialized the string variable z, and then now we have to go ahead and print it. So now what we're going to go ahead and do is press compile and close. And then if we go ahead and run the main method at this point, indeed we see Claire, because that's what we went ahead and assigned the name instance variable to in the default constructor. So hopefully you understand how that works. And then you can have other types of constructors too. So what if you just fed in one string? What if you just fed in their name, string n? And you can call it string t if you want, right? But what if you just fed in a string? Well, then you would have to go ahead and give their name something default. So you could say name equals n, but this would be like basically a halfway default constructor, because essentially you're going to have one default value, but then you can assign one of them, right? Because they would only be passing in one string. But if you want to give them the functionality of just being able to pass in one string, you have to write this constructor. You have to define what it actually does. So let's say that we're going to make their age 53, okay? And so now what you do, and we can go ahead and test this one too, right? Because now what we do is if we create a person object with just by passing in a string of Kevin, now what we can do is ask for that person's age. So we could say a.getAge, and now we could figure out how old Kevin is because we've created a constructor that just accepts that string. So now what we do is we go ahead and see that Kevin is 53. And the Claire is from the other object, right? The Claire is from z, which was from y. So that's just from previously. The next thing that I want to talk about is called a toString method. A toString method basically allows you to define what it means to print an object. And you have to write it in a particular way. So you have to call it toString. And it doesn't accept any inputs, okay? So basically, this is literally your method header. So this is an official method header for the toString method. But basically, what this method does is it allows you to define what it means if you just wanted to print a person object. So basically, if you remember from lesson 5 and 6 when we were talking about string methods, we said that if you call the toString method on a string object, it simply returns that string, right? So it's pretty obvious what it means to print a string. We could just print the letters in it, and Java knows how to handle that. But if you print a person object and you don't define the toString method, basically what happens is it prints a very strange code that is not very helpful for understanding the object. So what if we wanted to have a string representation of A? So we wanted to just print the person object A. And we said that the person's name was going to be Kevin, but Java doesn't really know that. That's for like a human's purpose, is that we're assigning this name instance variable to Kevin. So what happens if we actually try printing that person object? What do we get? We get this strange sort of memory address thing. So we get person at 1328DEBC, and that's not very helpful. So what we do is we create something called a toString method. And what we're going to do is we're going to say public string toString. And that's an official method header for a toString method. And so that was exactly how it would be looking here. And so what you're going to do is you're going to say public string toString, and then it's up to you to return a string that you think is a good representation of that object. So what I mean by that is, for example, what would you want to have printed on the console if you were wanting to print a person object? Well, for example, I think it would be helpful to print the person's name and then concatenate it with a string that says is, and then you could concatenate it with their age, and then you could concatenate it with years old. So for example, if you created a person called Tom with an age of 87, then what we could do is we could return name concatenated with the word is, remembering the spaces on either side of that word, concatenated with the person's age, which is an integer, but we said in less than 7, and that's correct, less than 7, that ints are basically converted to or implicitly cast to strings when they're being combined, concatenated with strings. So return their name, and then is, and then their age, and then years old. And then you have to have a semicolon, right? So this is a string. And if you had wanted to basically define that string first, you could have done that. So you could have said, okay, call Q all that stuff, and you could have said return Q. So now what we're going to do is we're going to compile this. We're going to look again at the person tester. And now let's go ahead and delete the Claire stuff. We're just going to delete that. And so now we just have this Kevin thing, and we can figure out what's going to happen if we just try printing that person object. So we have now a couple of examples here, right? Because we talked about how we could have different types of constructors where we pass in either no inputs at all. This is called a default constructor. Or then we went ahead and created a third constructor where we just pass in a string. So if we just pass in their name, then we have to give a default value to the other instance variable. So we give them a default 53 for their age. But we're just going to say person A equals new person of Kevin. And so now we can figure out what's going to be printed. So now what we did, well, we said name is going to be Kevin, right? The string that we're passing in, and age is going to be 53. And then if we scroll down and look at the toString, what does toString do? Well, it creates a string object called Q, which is the name of that person object, right? It's not static, it's another instance method. So we can say that this is an instance method, which is a string representation of an object. You get to define what is printed if you try printing an object, what is printed on the console. Okay, so that's up to you. So string Q is their name, and then is, and then their age, and then years old. And so hopefully you can predict that we're going to get, you know, that what did we feed in for the string? Okay, and then what is the default value for the age? And then you combine those two things, and you can predict what we're going to get. So we get Kevin is 53 years old. Okay, we can create another type of object with a different constructor. So what if we did person B equals new person? So now we're using the really default constructor. So now if you look at the default constructor, what default names did we give? What default values did we give to the name and the age, right? So if we scroll up, remember we gave their name the value of Claire, and their age the value of 29 if no inputs are passed in. And here with B, we're passing in no inputs. So now if you say system.out.print ln of B, not only are we going to print Kevin is 53 years old, but we're also going to print Claire is 29 years old. So hopefully that gives you a good understanding of the default constructor, and just the fact, and a little bit more generally, that we can create whatever types of constructors we want with different combinations of inputs. So I gave you sort of an example of that here just by passing in a string. And then also a toString method, which is a helpful representation of basically an object. And you don't have to call .toString. You can just literally try printing that object and define what will be printed on the console if you did that. So hopefully that was helpful, and we'll continue our discussion of object-oriented programming in the next video. From UMills03, thanks for watching, and please subscribe.